All right, we are looking at the 9.2C practice quiz today. Starting off, it says, I flip a fair coin 10 times and record the proportion of heads I obtain. I then repeat this process of flipping the coin 10 times and recording the proportion of heads obtained many, many times. When done, I make a histogram of my results. And the first question says, about where will the center of my histogram be? Use appropriate notation to describe this fact. So what you need to think about is if you're flipping a coin 10 times and you're recording the proportion of heads, you would expect in the long run there to be about 5 heads out of 10 flips because there's 2 outcomes and the probability in the long run is just the number of outcomes. There's 2 outcomes, it's half 50-50 shot. So the notation for describing the fact that you will have 50% of the time you'll have heads would be the mean of the sample proportions. The mean of p hat is going to equal the population proportion p, which is equal to 0.5. That's the proportion of heads that you're going to obtain. Question 2, what is the standard deviation of the sampling distribution of the proportion p hat of heads obtained? The formula for standard deviation is sigma of p hat is square root of pq over n. If p is 0.5, then q is also 0.5. Q is just the opposite outcome, or 1 minus p, divided by n, which is 10, because you're flipping it 10 times. You plug this in your calculator, you're going to get 0.1581. Question 3, describe the shape of the sampling distribution of p hat. Justify your answer. Because you expect the center to be at 0.5 and this is going to be symmetric around the middle of 0.5, but you can't guarantee that it's going to be normal because NP and NQ are only 5 in this situation. And in order to assume approximate normality, these numbers need to be at least 10, which is one of the conditions that you read about in the chapter 9.2. Then it says, let's go shopping. Are attitudes towards shopping changing? Sample surveys show that fewer people enjoy shopping than in the past. A recent survey asked a nationwide random sample of 2,500 adults if they agreed or disagreed that I like buying new clothes, but shopping is often frustrating and time-consuming. In this survey, 1,520 people agreed. The population that the poll wants to draw conclusions about is all U.S. residents age 18 and over. Suppose that in fact 60% of all U.S. adult U.S. residents would say agree if they were asked the same question. So question 4 says, what is the sample proportion of U.S. adults who agreed with the statement? The sample proportion is the sample amount who agreed over the sample size, 1520 over 2500, which comes out to be 0.608. Question 5 says, if in fact the proportion of all U.S. adults who would agree with the statement is 0.60, what is the probability that this proportion in a random sample of 2,500 adults is as large as or larger than the result of this survey? Be sure to check any necessary conditions are met. So the concept of finding a probability as large as or larger than the result means that you are finding the probability that p hat, the sample proportion, is greater than or equal to, as large or larger than, the sample proportion, 0.608. And the way you do this is you use the normal CDF command of the z-score that you would obtain up to positive infinity. It's up to positive infinity because it's greater than. So the way you find the z-score is you do the z formula, x bar minus mu over sigma. X bar is 0.608, mu is 0.6, and sigma is calculated down here by doing square root of pq over n, like we did earlier in the quiz. P and Q, P is 0.6 in this scenario. That's the actual population proportion of people who agree. And Q would be 0.4. And the sample size is 2,500. When you put this in your calculator, you're going to get 0.0097, and then 97 repeats forever. So I plugged that in up here, got my z-score of 0.8165. That's how I got this number. Up to basically infinity, I wrote 10,000. And that command will give you the proportion of 0.2071. But I also need to check and make sure that the conditions are met to make this calculation valid, that will allow me to use the normal CDF command. So I checked the conditions. The first condition that you need to check is that the population size, capital N, is at least 10 times your sample size. And our sample size was 2,500. 10 times 2,500 is 25,000. And since our population is all U.S. adults, all U.S. adult residents, they also mention it up here, all U.S. adult residents age 18 and over. Obviously, there are at least 25,000 adults in the United States, so that condition is met. The other condition that you have to check is that NP and NQ have to be greater than or equal to 10. So I checked that down here. N is 2,500 and P is 0.6. 2,500 times 0.6 gives you 1,500, which obviously is greater than or equal to 10. Similarly, NQ is 2,500 times 0.4, which gives you 1,000, and that's also greater than or equal to 10. So I said, therefore, that's what these three dots mean, therefore the normal approximation can be used, which allows me to use the normal CDF command. When you run the command, you get this number. That is the proportion that you would, that's the probability that the proportion could be as large as 0.608 or larger in the survey. So that's the 9.2C practice quiz.